What I just want to do is I just want to look at the steps again. So if you guys want to just turn back to your steps. So the draw diagram partway through the motion, not really the snapshot at that point, but that could be considered the snapshot too, and label all your key variables. If you're a visual person, I mean, I'm very visual, right? If people just tell me stuff or whatever, I just kind of like glaze over pretty fast. But if you're showing me at the same time, then I can kind of understand what's going on. List all the different rates of change, right, that you have. So if they give you the change of area, that's dA over dt. Get all those, you know, and then which one you're looking for. Maybe they want dr over dt, right? Find the equation relating all the variables. Today, that was Pythagoras, or pi r squared. Today, number 4 is going to be much more applicable. If there is a variable that is not on the list, you need to remove it. Not mostly because of the variable, but because when I do the derivative, I won't have the derivative of that variable either. So it instantly gives me 2 more unknowns. And when you got too many unknowns going, you know it's impossible. You're going to have to walk away from that one because there's no way you can solve it with 4 unknowns. And then take the derivative implicitly. Now, taking the derivative implicitly, that could happen at any time. Sometimes it's easier to do it higher up because how do you know what to go look for or get rid of or whatever until you do the derivative and you see the problem. And then you substitute all the values in and solve. And then sometimes you got to go back to the original formula and then you express in proper units. So these steps may make a bit more sense now that we've done a few yesterday. Now we're going to kind of do yesterday's on steroids here a bit and do some okay, so we're just going to do 3 questions today. 3 little questions. How hard could that be? You're in, you're out. Okay, so we'll go into question 5. Now the area of a triangle, equilateral triangle. We all there? What's wrong? Oh. Okay. Okay, so you might want to write in the stuff that's underneath. The area of the equilateral triangle is decreasing at a rate of 5 centimeters per second, or centimeters squared per second. Find the rate at which the side is changing when the area is 250. Okay, so I don't know if you can picture an equilateral triangle that is shrinking, right, at a rate at 5 centimeters squared per second. Find the rate at which the side is changing. Okay, so we'd be looking at ds over dt. So just to get an idea of what we're talking about here. Where's my equilateral triangle? They don't give me one. Okay, we'll make this one equilateral. I guess not. Let's go. Okay, so get an equilateral triangle, and obviously the simpler the question is, sometimes the harder it is, because you're like, okay, got myself an equilateral triangle. I mean, maybe do something like this, tell yourself, yeah, right, they're all the same. This thing is decreasing with an area of negative, or it is decreasing at a rate, so it would be dA, right, over dt would equal negative 5 centimeters per squared per second. So that's huge, right? Want to have that negative there, and maybe you want to just draw an arrow to decreasing. So you're kind of always checking to see that those line up. And again, if I was making a study sheet, I would get like a really hard example on there and write down all those little things. Arrows here, you know, little notes to myself. So maybe if I got to use that study sheet on the test, I can be double checking, oh yeah, I had to do this first, I had to do this. But the one thing that you will find if you use your study, if you study your sheet enough, as soon as you walk into your test, you'll remember that question identical on your study sheet. You'll be able to do it anyway. Because obviously in university you're not allowed to bring one in, but if you go over it enough, you'll remember everything about it. What are we looking for? Right, so what is that? Like how would I write that? ds over dt equals question mark. At or when area is 250 centimeters squared. Okay, so we're gonna totally do this question I'm not gonna give you anything. Obviously, I know the answer, got it right in front of me. But sometimes the teacher just writes all this stuff down. You're like, wow, how did he get that? No idea. Okay, so I got all this. Hopefully, I haven't done anything that you guys wouldn't do at this point. Now, what do we do? Okay, we need a formula, but the one thing we haven't done that I would recommend doing is labeling your diagram. Okay, like I haven't labeled anything on it yet. I got this triangle, well drawn triangle, like you say with myself, and with ticks on it. That's it. That's all I got. Can I put any letters on it? Can I put any variables? Can I? What? Okay, but what should I call them? S? Well, if I'm calling that ds over dt, it would make sense that I would call these all S. So what would be the money formula that would have A and S in it? Because obviously I need a dA over dt and a ds over dt, right? So what's the formula? So area equals 1/2 base times height, right? That's our formula. Okay, so that means I got to come back to here because I only have a height. So if I'm going to be using this formula, I guess I better be having a height there. And what's this here? 1/2 S. Now if you can just think, now this is the product law if I was to do the derivative on this, correct? So if I did the derivative on this, I would have dA over dt. I would have dB, which is S, right? Everyone, 1/2 S over d, and I would have dH over dt. That's a lot since I do not have dH over dt or ds over dt. There'd be two rates that I would not know. And what you really are going to struggle ever is finding rates with a snapshot. You can find sides with a snapshot, but you won't find that rate. So of H, or how do you do that in a snapshot, right? So which one of these variables do you think we should get rid of? We got to get rid of H. Now, most of you would do the derivative and go, wow, okay, I got too many rates, I do not know. And then you'll back up and then you'll try to get rid of it. Okay, and that's okay. That's how you get through these. So we need to get rid of H. Okay, and why we don't want dH over dt to have to deal with. It's just that simple. You don't want to make things more complicated and more unsolvable. If you had dH dt, you'd have ds dt you don't know, dH dt you don't know, you have H you don't know. So how are we going to get rid of H? Okay. Okay, so we have, I'm going to just, so people at home. Okay, so we do have, right, the way that we can relate S to H. Okay, and we can use Pythagoras, right? So we know it would be H squared plus 1/2 S squared would equal S squared. Okay, does that make sense? So H squared would equal would equal plus 1/4 S squared would equal S squared. Let's get H squared by itself. If I got S squared minus 1/4 S squared, that will be 3/4 S squared. Now I need to get H equals, so I'm going to take the square root of both sides. Now most times you should be taking plus or minus, but if I'm getting negative distances, that's not going to obviously work. Yeah, something's wrong. So H equals root 3 S over 2. I subtracted 1/4 S squared. Okay, now if we take, so I don't know, we should probably start. This is like first thing I did. Then the second thing I realized. Okay, then third. Now fourth is we have our formula, area equals 1/2 S times height, right? So I now know height, so I'm going to take this and I'm going to sub it into there, and I will have area equals 1/2 S times root 3 over 2S. So area would equal root 3 over 4S squared. Okay, and that's a huge deal to get to that point, because it's actually kind of home free from here. So we're running out of room, we'll come up here. So now we have two variables, which is nice. Okay, so we'll have, let's do a derivative then. I got dA over dt. There's actually a trick I could show you too. Well, actually, that's more for max min. We won't have to do that right now. And then if I'm going to bring the 2, that would be root 3 over 2, right? S times ds over dt. So the squared from here came down here to be a 2, and then the 2 and the 4 turned into 1/2. Okay? So brought the derivative here, and then I had 2/4, which is 1/2. So there could be a 1 there if you really wanted it. Okay, dA over dt. I know it. S. Don't know it. ds over dt, looking for it. Okay? So now well, basically when we got to here, we were at yesterday. Okay, yesterday was take it, derive it, do a snapshot, get some stuff in, and then solve it. So this here, step 3, is that new step that I had to put into place because I would have had way too many variables. The rest of this now is the same. So let's do a snapshot because right now S is eluding me. What's wrong, Danny? Well, I took B as S, right? More specific to this question. 1/2 base times height is the general formula, but mine was S. No, when you're doing an entire triangle, right, it's 1/2 S times H. The reason I had to put that half S in there was for Pythagoras. Okay, those are good questions, because you're probably not the only one. Okay, snapshot. Now, we know that area equals root 3 over 4S squared. Okay, and it says the triangle, the area is decreasing at 5 centimeters per second squared. Okay, no, can't use that because that's dA, right? Sorry, it says the side, find the rate when the area is 250. Sorry, not dA, but the area. Okay, so it's our notes, right? So let's put an arrow here so later you're not wondering where that 250 came from. So 250 equals root 3 over 4S squared. Root 3 over 2. No, root 3 over 4. That's my derivative, root 3 over 2. Okay? 4 will come up to be 1,000. 1,000 divided by root 3. And then square root it. Get what? 24.03 equals S. Okay, now we got 7. Let's solve. So there's always two ways to do this. You can put all your numbers in and then solve. Some people find that easier. Some people don't. To me, I like just dealing with the variables. But I'll do it by subbing it in first. So dA over dt. So we're using this formula right here. So we get, how do you get what? That's my derivative of this. dA over dt equals 2 times 3/4 over 4s times ds dt. My little arrow there. Okay. Now, let's solve it. So d, that's -5 equals root 3 over 2 times 24.03 ds dt. Okay, so this would be 2 times -5 over root 3 times 24.03 equals ds over dt. And you will get -0.24 centimeters per second. Okay, so we would say the sides are decreasing by 0.24 centimeters per second. I guess we could say when area equals 250 centimeters squared. Okay, so you can see they're a little bit involved. Okay, 2 more. Okay, so I'm going to start stepping back a bit here and getting you guys to tell me what to do next, or do first, or whatever. Okay, we got sand is poured by a conveyor belt at a rate of 2 meters cubed per minute, forming a pile in the sand of a right-angled cone where the radius is always twice the height. How fast is the height changing at the moment when the height is 4 meters? Okay, where do we want to start? Draw a picture. It's not a very good picture actually because radius is always twice the height, so it's going to be more of a pile like this. These take a lot of room, so I'm going to try conserve real estate while I can. Okay? Anything else? Okay, what do we know? Okay, so what's the rate of sand though? I need to write it down in derivative. dV over dt equals positive or negative? Positive. So I'm going to be intentional by putting the positive there. Means I checked. Okay. What else? Okay. Well, so we know this is the... So what are we looking for? Because I always say we're looking for this when it's 4. What are we looking for? We're looking for dH over dt equals question mark when h equals 4 meters. So I always like to do that statement. I mean, if you're at all struggling with these, try and do the same thing every time you do a question, and you're going to be way more successful. So draw that picture, or get everything down. Now, is there anything more that I should write down? Sorry? Actually, yeah, and this gets really, this always messes with students' heads, even with me sometimes. Is it 2h equals r or 2r equals h? And the radius is twice the height, right? So the radius equals 2h. That's our formula. Okay, I'm just kind of putting down everything. It's nice to be able to get rid of the sentences in the paragraph. And okay, we know this is R, right? Okay, so next we got our formula, or sorry, we got all the stuff we're looking for. We've got our picture. The next thing, yeah, you want to find a formula, and since it is a cone, and dV over dt is in there, we're going to be doing volume, is 1/3 pi r squared times height. Now, which variable is going to cause us some grief? Okay, that's a good question. It's either height or r, right? Radius or height, which one? Because if you look up here, radius is definitely going to be the problem. We want height. If we got rid of height here, we would be cruising along for a while and go, oh crap, I needed that one. Okay, so don't get rid of something you need. So there's the indicators, right? So you need to get rid of our, no, just in this one. See, dr over dt would be a pain in the butt to have, and then I don't know the radius, so there would be two areas there that would. So since we know this, we can sub it right in. V equals 1/3 pi times 2h squared times h. Okay. So let's kind of try and clean things up a bit here. Volume equals 1/3 pi times 4h squared times h. So volume equals 4/3, 4 is coming over, times pi h cubed. What's really nice about this one is you don't even have to do the product law because there's not two variables, right? Pi is not a variable. Always remember that. It is 4 times 3.141592 divided by 3. This is all considered, right, a coefficient in front. Okay. So what should we do next? Do the derivative. Okay. What would the derivative look like? dv over dt equals 4 pi h squared dh over dt. Okay, do I need a snapshot? You don't even need a snapshot for this one. You've got everything you need, and that happens a lot when you're dealing with circles, cones, that sort of thing, spheres. Okay, so we know that dv over dt is 2. It's 4 pi times 4 squared dh over dt. Okay, so 2 equals 4 times 4, 64 pi dh dt. That's going to be 1 over 32 pi equals dh over dt. The 2 over 64 would reduce to 1 over 32. So the height is changing at a rate of 1 over 32 pi meters per minute when the height is 4 meters. Okay, any questions on that one? Okay, so one more. Again, this is something you're going to see obviously on your unit exam. Ryan, you with me here? Something you're going to see on your unit exam. One question, one big page, right? So you can see that a lot of things, Rebecca, you might want to watch this. You see a lot of things that will be worth marks. Yep. I don't know, could 6 to 8 marks around there. Yeah. Not 68, 6 to 8. Okay. And look at this, eh? Diagram's drawn already. What's the use even working on this one? We'll go through it anyway. A water trough is 10 meters long. 10 meters is even labeled for you. This is why this is called the entitlement era in your lives. And a cross-section of an isosceles triangle with a base is 0.8 meters and a height of 0.6. Water is emptying from the trough, so there must be a bit of a hole, at a rate of 2 meters cubed per minute. Find the rate of change of the height of water when the water is 0.4 meters deep. Okay? So, find the rate of change of water. So I want to know how the height, like, obviously the height, it's going to go quite slow at the beginning. Not changing the way that it's emptying, but it goes down much quicker at the end, right? The height does change quicker the closer it gets to that vertex. Don't even have to draw a diagram. That one's done. What else? What should we do now? We've got dV over dt. Very good. Negative 2 meters cubed per minute. Okay. Anything else we should write down? So dH over dt is our unknown when h equals 0.4 meters. Okay, so we always did what we're looking for, diagram. We always did those 1, 2. What did we always do next? Get a formula to relate all of this stuff together. Okay, so we got volume of a prism equals area of the base times height. What is our base? Is it rectangles, triangles, what? It's triangles. Remember, a prism, the way it sits, to be a prism, all the sides must be perpendicular to the base. If you sat this on a rectangle, one of the 3 rectangles, not perpendicular to the base. The only way you can set it up is by putting it on the triangle, therefore it's a prism. Okay? So, this is a triangle times the height, right? So volume of the prism is area of the base is 1/2 AB, or I'll use BH because you guys always get scared of. Now, we got a height in there and we got a height out there, so that's why you should always use AB, but you guys always freak out about that, so I'll just call that length then, the length of our trough, which would really be the height of the prism. Okay, now this is what is highly unique about this question, but there is a variable that we can actually fill in right now because it never ever changes. The length, okay? No matter what, height changes, right? Base of that triangle changes as the water goes down, but the length never changes. So why is that important? Because I think you're going to try to get rid of it later, because you're like, I got to get rid of that thing, and you're going to try to come up with some formula or whatever, and just make sure you're not putting like 0.6 or 0.8 in, because that is changed. When it was full, that would have been the base, and the height would have been 0.6, but as that goes down, that always changes. That might be part of our snapshot, but it won't be consistent throughout. The length will be the same in snapshot, without the snapshot at any time. So BH times 10, okay? So, and make a note here, it's not changing. Right? The reason that we're doing calculus is because now we can find specific points of rates when in time, right? If it wasn't changing, then we would be doing a what's called just a consistent rate, which is what you don't need calculus for. So that's not changing. And just to kind of clean everything up, we have this formula. Now you can see when I'm marking these and I see that and I go, okay, that's good. Like that's worth some good marks there, right? To be able to put that in there. And you can see how this will fall apart if you put in, say, the 0.6 or the 0.8 right now. Now, then we do kind of a, let's think ahead a bit. We do know dV over dt. We do want dH over dt. So that base, right? That base is not going to be good for us because we're going to, then we'd have to find B over, or dB over dt and B as well, right? There's two things that wouldn't be good. So just, and you know what? You write this stuff, you got to get rid of B. Right? When I'm marking this, it really helps me understand that you know what you're doing. Good question. How do we get rid of B? Okay, use this formula to see what B equals. Because this is B, right? This is H of the original triangle. Yes?
The angle between the base of that triangle and the two arms of it is an isosceles triangle that isn't going to change the left or right. So you have to figure out that angle. Because it's going to be the same angle in the one.
Yeah.
Okay, so you find that angle, and then with that, you can figure out what B is going to be at the water level, like H being 0.4. And then once you figure that out, you can plug it in.
Yep. So, yeah, I'm not saying that wouldn't work. I want to try that. That should work. That should work because, but what you're saying is that this angle here stays consistent no matter what, right? It does. No, that's good. So what you're saying is that this triangle here kind of relates to this triangle here, kind of relates to this triangle here, right? So if you want to simplify it even more, those are similar triangles, right? And you were using the same thinking. So that should work. And I'd challenge you to try and see if you can get the same answer. You should. Oh, ooh. Looking pretty tough, yeah, exactly. Work me out of a job up here. Okay, so let's use similar triangles. I'm not going to tell you if it's right or wrong, but tell me what you got. Yeah.
Well, negative 0.375.
That might be right. No, that's good. Okay. No, it should work, because if you're using similar triangles, you're saying that angle's the same. So yeah, that would work. Okay, so let's get we'll use similar triangles. Because when you have a scenario like this, these triangles are similar, okay? And that's why using that angle down there would work. So this is 0.8. And this is 0.6. And that, I'm going to call this, if you can see this, that's going to be my B and my H of my red triangle. So B over H should equal B over H. Right, does that make sense? So we could call that like the small and this the large. So I do not know this or this, but I know this one is 0.8 over 0.6. Now, you don't have to do this, but it does B over H does to get rid of decimals, because you don't really want decimals in a fraction. Yeah, that would be 4 over 3, right? And then I would just multiply both sides by H. So then I would have B equals 4H over 3. So what did you substitute in?
I figured I plugged H into that. Well, I mean, first I did the angle, which was 56.3, ridiculous angle.
Mm-hmm.
And then I used just sine law and tan and everything and stuff to figure out what B would have been smaller triangle. And plugged B in. And
Oh, so you plugged it in at that snapshot time. Oh, okay. Well,
that's my
right.
It should be consistent over time.
Yeah, the only thing is that at this point, when I get this formula, so you'll see the disadvantage to your way is if you had to just come up with the equation for this, because now I can plug in any H and get it. Right. Right, you only have for the one. So if I was just looking for this, right, you wouldn't be able to do that. That's at the snapshot time, okay? So if I come up with a general formula, I can now throw anything at you. And if I had to throw 5 different times at you, it'd be quite fast. Otherwise, you'd be doing it 5 times and keep doing. Yeah. Yes. And you always got to ask you always got to think, well, what do they want, right? So this is V equals 20 over 3H squared. Yeah. Whenever you have similar triangles, they're in ratio to each other. They have to be, right? Like 0.8 to 0.6, they will keep that same ratio all the way down. You could, if you wanted, you could do 0.8 over base equals 0.6 over height. You could do it that way too. Does that make more sense? Yeah. Yeah. So you're doing base to base equals height to height. Yeah. You should get the same thing, I hope. Yes, you would. Okay, good question. Okay, so this is that's a nice thing right there because the derivative doesn't even look that ugly. So now let's do the derivative. We got dv over dt equals 40 over 3h dh dt. So when you did your derivative, you didn't even have an h in yours.
No. I was
Oh, you did the derivative first and then subbed it in, or what?
Yeah, no, I subbed my V in before I did the derivative. So I ended with dV over dt equals 2.66 continued dA over dt.
Okay. Where we're going to put it in right now to get, we should get the same thing actually. Yeah, for this one. Okay. So let's plug it in. We know dV is negative 2 equals 40 over 3, 0.4 dH dt. Okay, so if we just want to see what it would look like, I would bring the 3 up here, and the 40 times 0.4 would be down there, equals dH over dt. Okay, and this would work out to be negative 3 over 8 equals dH over dt, or negative 0.38. Answer to 2 decimal places up here, so. Okay, so the height is decreasing. At a rate of 0.38 meters per minute. Actually, that should be, yeah, meters per minute. That's right. When the depth is 0.4 meters. And that's what the homework looks like when it's not on top of something. All good? The trick is to do as many as you can, but be consistent in how you do them. Keep an eye on the solutions, of course. Number things, draw arrows, get a good example on a study sheet to help you lead through this stuff.